Okay, independent practice on this lesson 17.3. Let's start with this first one here. Right, my little pointer. And so a spring stretches in relation to the weight hanging from it according to the equation. Here we go. Where x is the weight in pounds and y is the length of the spring in inches. Okay, we got to graph this. So first we have to start with our y-intercept. And that y-intercept is this right here, 0.25. Well, we should know that if this is 1 right here, then each of these go in increments of 0.25. So I'm going to use that. This is 0.25. You know what? I better zoom in a little bit more here. Because this is, okay, 0.25, and then this is, whoops. I need to use my pen. This is 0.50 and 0.75. So 0.25, that means that we are right here. That's our y-intercept right there. And then from there, we're going to use the 0.75. But 0.75 is 0.75 over 1. That's our slope. Rise and run. Go up 0.75 and go to the right 1. I'll use that. So go to the right 0.75. I'm sorry, go up 0.75, which means I have to go up 3. 1, 2, 3, and over 1. But 1 is all the way over here. So notice here I had to go up 0.75, and I had to go to the right 1. Okay, now I'm going to do that another time here. I'm going to go up 0.75, which means I go up 3 of these little grid points. 1, 2, 3, and all the way over to 2. There. And I wish I had a straight line tool, but I'll do my best. And this just keeps on going in this direction here, like that. There's the graph. All right, let's see what else we got here. Graph it, interpret the slope and the y-intercept. Okay, well, let's see, the slope. Slope is, let's see, it's the rate of inches to weight. Right? Isn't it? It's the rate at which this stretches, because it's going to stretch 0.75 for each pound that's added. That's the rate. Rise and run. Okay, and let's see what else we got here. Oh, and the y-intercept. The y-intercept. Y-intercept is the length of the spring with no weight attached. Yeah, see? If you don't attach any weight to this at all, then it's going to be 0.25. So, okay. I hope that makes sense. Next, how long would the spring be if a 2-pound weight is attached to this? Well, let's see. We could answer that right here. If 2 pounds, that would be 1.75 right there. Done. That's easy. So, what? 1.75 pounds. And will the length double if you double the weight? Let's see. Is there room for 4? Okay, there is. So I'll double the weight there. And I will, let's see. I'll make another mark at, I'll go from that dot, the blue dot, the last blue dot, I'll go up 3, 1, 2, 3, and all the way to 3. Okay, and then to double the weight, I have to go from 2 pounds to 4 pounds. So I'll go up 1, 2, 3, and over to 4. And so this just keeps on going this way like that. And the weight here is 3.25 pounds. 3.25 pounds. And so did it double from 1.75 to 3.25? No. So I would say no, it won't double in length. And we would know this also because this is not proportional. Right here, it doesn't cross the origin, and it's not proportional, so it's already not going to do what I just said it wouldn't double. Okay, these are tough. These are really tough for students. So identify the coordinates of the 4 points in the line with each given slope and y-intercept. So if you're given the y-intercept and the slope, let's make some points. Okay. So first, if the y-intercept is -1, well, we got a point then. Then the first point would be 0, -1. Because if I were to, I'll do this here and then I'll have to erase it, but 0, -1. 0, -1 is this point right, oh, I'm sorry, it's this point right here. And that's the y-intercept. And then from here we go up 5, 1, 2, 3, 4, 5, and over 1, and we have another point. In fact, actually, I can do that right here. I would have 1. So the coordinates of, this is our line here. The coordinates of this bottom point are 0, -1, which is what I just wrote down. And then the next point I can see here is 1, 4, 1, 4. So the next one would be 1, 4, because I applied the slope of up 5 over 1. Now, let me slow this down just a little bit. Let me erase this. Now, the slope is the change in the y values over the change in the x values. Now, if the slope is 5, why am I doing this so crammed in here? I don't have to cram it in. I can just go over here. I can zoom out and bring it over here. So let me do this. The slope is the change in y over the change in x. And that slope we're given is 5. Well, 5 is the same thing as 5 over 1, and I made it a fraction so I can see, oh, the change in y is 5 and the change in x is 1. And if I have well, I mean, I could go off of this one here. That would be pretty easy. Remember, the 1 is the x value and the 4 is the y value. So if I were to create another point, I'll get this going. So I'm going to create another point. And so if the y value is 4, and I have to add 5 to that y value, that's 9. The new y value is 9. And the x value, notice here, so the x value is 1, and I have to change the x value by 1. Then that means that the 1 plus the 1 value is 2. The x value now is 2. That's the next point. And to get the 1 after that, I have to change the y value, which is 9. And I have to add 5 to that. So 9 plus 5 is 13. So the next y value is going to be 13. And the next x value, well, the last one was 2. And I have to add 1 to it every time, right? Because the x values all change by 1. And so we have 2 plus 1 is 3. See? Oh, we got 4 points right there. Okay. Let's go on to the next one. I'll put it over here. Now, our first point we hopefully will see is 0, 8. That's our first point because I was looking at this right here. I said, oh, 0, 8. Y-intercept is 8. There we go. Now I'm going to apply the slope of -1. Now, the slope is the change in y over the change in x. And the slope is given as -1. But I need to make it a fraction, so I would make it -1 over 1. Now it tells me the change in y is going down 1. So I'll say, how about I spell this out a little bit better? The first y value is 8. So that would be 8. And the change in y is going down 1. So it's going to be 8 minus 1, which is 7. And so with this, the next y value would be 7. And with x, the change in x is going up 1. So the change in x, let's see, the first x value is 0, and it's going up 1. So that would be 1. Whoops. Hello. Make it 1. And so that would be 1. Okay, great. Next, the change in y is going down. Well, could I just do this quickly here? So, this is the y values are going down by 1. So the y is 8, 7. It's going to be 6, right? That's going to be 6. And then the next one, the next y value is going to be 5. And then we could have the x values are going up by 1. So it's going to be 0, 1, 2, 3. 2, 3. Okay. Next, this here. A decimal. I mean, how does that work? Well, let me show you. I'm going to erase this a little bit here. And this is going away. And I think that what we got to do is we got to continue thinking about this whole slope. Well, okay, how about this? Super easy part. We know that the first point is going to be 0, 0.3. Okay, now we need to figure out what the next one is. And I'm going to use that slope. So again, slope is the change in y over the change in x. And this is 0.2. Now, you could make this 0.2 over 1, but I was thinking something different. How about this? 0.2 is the same thing as 2/10. And I could simplify that to 1/5. And now I can see that the y changes by 1 when the x changes by 5. So the change in y, the first y value is 0.3, and I have to add 1 to that. And yeah, so it's the first y value is 0.3, and the change in y is 1. So that's going to be 1.3. So the next y value is 1.3. Now the change in x, that first x value is 0, and it changes by 5 right here. That's what I found out here. It changes by 5, so it's going to be 0 plus 5. 0 plus 5 is 5. And so there's your point. Now, let's go a little bit faster here. So this is changing by 1, so that's going to be 2.3, and this is changing by 5, so that's going to be 10. So this is going to be 2.3, and this is going to be 10. And then we can go even faster here. We can just say, well, 2.3 adds 1 to that. This is going to be 3.3, and 10 increases by 5 to 15. Yeah, there's 4 points. Not looking so bad anymore. Okay, number 9. Let me get that. Okay, I'm going to erase this part here so I have some room. But I'll keep the change in y over change in x. So the change in y is 1.5. So this is 1.5 over... I'll keep it as 1.5 and 1. I don't think that's going to be a problem. So our first point is 0, -3. Because I saw that, that one right there. Okay, now the x values change by 1. I noticed this here. This is going to tell me, well, that's going to be super easy. I'm just going to do, since the x value is changed by 1, I'm just going to say that's 1, that's 2, and that's 3. The y values are going to increase by 1.5. So first, so the y values are going to increase by 1.5, and I'm starting at negative 3. So change in y, let's see, negative 3 plus 1.5 is negative 1.5. So this is going to be negative 1.5. Now, then negative 1.5 plus 1.5, that's going to be 0. So that's the next one. So I increase it by 1.5 again, so that's going to be 0. And then 0 plus 1.5 is 1.5, and this is 1.5. Not so bad. Okay, next we have this. Let's see. I'll bring this over here, and I will erase. And here. So the slope, I think that what we can do is we could see that the first point is 0, 4. And then the next point, okay, let's go with this again. Change in y over change in x. Oops, where's my eraser? Not doing anything. There we go. So the change in y over the change in x for this is negative 1/2. Notice I'm going to put the negative on top. That way I can do something with that. So that means the y value is going to go down by 1 in each case, right? I'm looking at this. The y value decreases by 1. So that y value, that's going to go from 4 to 3. That's 3. And then 2. And then 1. And the x values are going to increase by 2 each time. So that's going to go from 0 to 4, 6. 2, 4, 6. Oh, so easy now. This one, 11. We have a new problem. And so the first point is going to be 0, negative 5 after looking at this here. Okay, and then I'm going to go up 2 and to the right 3. So the change in y is 2. I'm going to go quicker with it. The change in y over the change in x is 2 and 3. So what this means is the x value, I'll go with the x values first. The x values are going to change by 3 each time. So that's going to be 3. From 0 to 3 is 3, and then 6, and then 9. Okay, there's 4 points. And then the y values are going to change by 2 right here. So these y values is going to increase by 2. So it's going to be negative 5, and then negative 3, and then negative 1, and then 1. Negative 3, negative 1, and 1. Adding 2 to each of those. Okay, that was a lot of work right there. So next we have this. A music school charges a registration fee in addition to a fee per lesson. Okay, so here's the music lessons last half hour. The equation, blah, blah, blah. Where's my pointer? Represents the total cost of x lessons. Find and interpret the slope and y-intercept of the line that represents the situation. Then find 4 points on the line. Okay, so slope. Slope is the cost per lesson. Oh boy. I believe it is. Total cost of y. Okay. For x lessons. Yes. Okay. And the y-intercept the y-intercept is the cost for 0 lessons. Or let's see, or registration fee. Okay, now find 4 points. Well, I know that 0.30 is one of the points. Is that really a 3 right there? 0.30. Okay, that's 1 point. And then because and how I know that is I know this right here. That's the y-intercept, and so 0.30 is going to be one of my points. Now, what's the slope? The slope is the change in y over the change in x, which is 40, and I can put it over 1. So now I'm going to use, and I found the 40 from right there. So the y increases by 40 as the x increases by 1. Well, let's increase the x values first. So the x values get increased by 1. So that's 1, 2, 3. Yeah, okay. And then the y values are going to increase by 40. So that means that it goes from 30 to, what, 70? And from 70 add 40 would be 110. And 110 plus 40 would be 150. Oh, I hope I got all those. 40, 40, 40. Yeah, that looks good. Okay. Okay, a public pool charges a membership fee and a fee for each visit. The equation y equals 3x plus 50 represents the cost for x visits. After locating the y-intercept on the coordinate plane shown, can you move up 3 grid lines and right 1 grid line to find the second point? Explain. Yes, you can. The question here is, so could you go up 3 and over 1, even though this represents 25 and so on? Because that's 50 and that's 25. 50, 75, 100. But this is 3. So 3 would be so tiny. 3 would just be like 3 would be over here. It'd be 1, 2, 3, and over 1, 1, 2, 3, and over 1. But the question is, could you use the grid lines here? So I'm saying yes. Explain? Well, let's see. Yes. Because each grid line represents 25. Our slope, is 3 over 1, which is equal to, if you go up 3 of these grid lines, that would be going up 75. And going to the right 1 grid line would be going to the right 25. So the slopes are the same. So yeah, that would be totally fine. Graph the equation. Okay, I'll do that. Include axis labels. Axis labels. Visits. Okay, so this is, they want labels, so visits and cost. So we start at 50, and I'm going to zoom in more here. We start at 50, and we go up 3, right? Yeah, I think, let me make sure here. So, yeah, we go up 3 of these grid lines, and then to the right 1. So we go up 3, 1, 2, 3, and over 1, 1, 2, 3, and over 1, 1, 2, 3, and over 1. Okay, I'm not going to connect these, I don't think. because you can't have fractional parts of a visit. Let's see, graph the equation, then interpret the slope and y-intercept. Okay, the slope is cost per visit. Y-intercept is the cost to get into the pool. Let me make sure I got membership fee. It's is the membership fee. The of the Yep, that says membership fee. How many visits can you get there for $200? Well, let's look at the chart. Did I do $200? Yes, right there. So $200, I can go 50 visits for $200. 50 visits. Okay. What else we got here? So, the hot questions. A student says the slope of the line for the equation is this right here. It's 20 and the y-intercept is 15. What is the error? Okay, well, it's y equals mx plus b. This is written in the wrong order, but we need to recognize this is y equals, this is m, there's the m and the x, and then the b. So we gotta see it's that way. So the slope is 15 because that's the number that's next to the x, called the coefficient. Or actually, the slope is negative 15, and the y-intercept is positive 20. So the slope is negative 15, and the y-intercept is 20. Yeah, there you go. Yeah. So suppose you know the slope and of a linear relationship that passes through the. Okay. So let's say you know the slope and you know a point that it passes through. Can you graph the line even though it's not the y-intercept? So let's say what they're telling you is, let's say you're given a slope of, I don't know, 1/2 and a point. Let's say that point is 1, 3. But notice that's not on the y-axis. That's not the y-intercept. So if I have 1, 3, 1, 1, 2, 3 here, and now that slope is telling me I have to go up 1 and over 2. So go up 1 and over 2 and put a dot, and then go up 1 and over 2 again and put another dot. You can do that. Now, I did this even though I'm not given the y-intercept yet. And so, yeah, I can graph this. You don't need the y-intercept. It's easy and nice, but you don't need it. I could go back. If I went up 1 and over 2, I can go down 1 and back 2. And down 1, back 2 would be something like here. And somewhere along the line, I could get that y-intercept. But so, can you graph the line? Yes. Just use the slope from the given point. Okay, next. Okay, graph these lines. Y equals 3x. So in y equals 3x, I'll say it's 3x plus 0. Now I can see that the y-intercept is 0, and 3x, that means that it's 3 over 1. So I start at this and I go up 3, 1, 2, 3, and over 1. And that's the same thing as going down 3, 1, 2, 3, and back 1. So here's this line here. And next, what else we got here? Y equals 3x minus 3. So in that, y equals 3x minus 3, that means I start at negative 3. That's the y-intercept, and I go up 3 and over 1. 1, 2, 3 and over 1. 1, 2, 3 and over 1. And there's that. And then the next one is y equals 3x plus 3. So y equals 3x plus 3, and that's over 1. So my y-intercept is positive 3. And I go up, I can't go up 3 and over 1. So I have to go down 3, 1, 2, 3, and back 1. Again, 1, 2, 3, and back 1. And I have that. Hey, they look parallel. So what can you do here? Here, all lines with the same slope, which these all are, will be parallel. And there you go. That's what you got to know.